Okay, so imagine you have a robot, uh, and you want to let that robot go about its business while you are programming it. And this is what multiprocessing in Forth is really about. So you want to control its direction and its speed as it's driving along a straight motorway in Germany somewhere. It's probably your living room floor, but just for the sake of fun. So we create two cues, one for speed and one for direction. Then we have a word to check the speed. So if you're driving slower than 100, then you're probably driving slower than all the cars on the motorway, so you should speed up. And it will tell you to speed up. These might be a little non-standard. This prints a string, so you put a string on the stack and then you print it. This one converts a string to a long, and this just duplicates them so you can test on them further down. You do the same for direction. So if you're veering to the left, then you should turn right, and if you're veering to the right, you should turn left. Now this one is reading the direction. It could be reading off a compass connected to the system, or it could be reading off some sensors on the steering wheels, or it could be reading the speeds of two motors if you drive a tank. And this is printing out the string direction, and then it's reading the contents of the direction cue, and then it's sending it off to this word check direction. So it will be using this will be a spawned background task that will be using a word defined in the main task. There is absolutely no problem with that, just in case anybody wondered. So here we do the same for the speed. We read it, probably maybe the voltage or whatever on the motors, or you may have some sort of speed sensors external to like in aeroplanes, for example, the air pressure or whatever. So it's reading this from the speed cue, and then it's what it's been reading, it sends it off to the word check speed, and then it will spawn those two words, the reading of direction and speed. It will spawn them as background processes. Now all of this to type in the string speed cue and then the cue to get it onto the stack, etc. Can be a little cumbersome, so you can place the speed cue in a variable, and you could even define a word that reads this variable and gets the value and everything. You could do all that in one go. And here you see it's reading now the variable that's called speed cue. This is not the same as the string. This is the variable, and it's sending it the value 210. It needs to be converted to a string before being sent to a queue. And then of course the system responds with slow down. And all the while this is running, you can create Forth code. And now the reason suddenly it prints speed and direction is because these have begun running in the background, and they are running all the way up to the reading of the Q. That's when they get suspended. So this is why they are allowed to run down here. This is handled by the operating system. Now we can set the speed to 90 kilometers per hour, and we need to speed up, so we set it to 120. That's the speed limit on most European motorways. And the same for the direction. We can continue to program in fourth. Now you see it has printed the value for the speed that we had, but it has not reacted to it. So it's reading the speed, and then it's printing the speed, which you see it has done here, and then it's waiting to see what's coming in on the queue. So it's suspended. Excuse me. And now the result of our fourth interaction is showing up here. So this is not the speed, this is the result of this. So let's veer off to the left a little bit. And we need to turn right, and we can continue. And again, this is not the direction that's been set to 90 degrees. This is simply this background task being allowed to run. It's being scheduled by the operating system scheduler, and it will print the direction, and then it will read from the queue, and there is nothing more coming in from that queue, so it will stop. When it did get something, then it got minus 34 that we entered up here, and it was told to turn right. And that's as close to a real world example as I'm ready to go right now. Thank you.